Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're going to see problem minimum operations to make array equal to target. Now, this is the fourth question. 3 and 2 will also be coming soon. If you like it, please smash the like, baby. Again, you know the drill. Yeah, it says that you are given two positive integer arrays, nums and target. As you can see, I have nums and I have target given with me. My ultimate aim, maksad, is that minimum operations required to make nums equal to my target. I have to make every element of nums equal to my target value. So 3 should become 4, 5 should become 6, 1 should become 2, 2 should become 4. Now, to make this, the operation which I can perform is in one single operation, I can take any sub-array. If I take any sub-array, I can increase it by 1 or I can decrease that sub-array value by 1. So, to make this array, again, to make this array 3, 5, 1, 2 equal to 4, 6 to 4, you know that whatsoever difference is there, which means 3 to 4, 5 to 6, 1 to 2, 2 to 4, that difference I have to ultimately cover. And in one operation, I can cover one sub-array, and that one diff I can cover either in negative side or in positive side. So ultimately, I know my maksad. I will take the diff only. That is what I have to ultimately handle. So I figured out, okay, I have to handle a diff of 1, a diff of 1, a diff of 1, a diff of 2 here. So now the task is minimum operations required. As you can see, answer is 2. But you might well think of, okay, Aryan, how to? So one way is I would have taken this as one subarray. This as, again, when I draw here, I am replicating this entire subarray. This as one subarray and other subarray as this one. Okay, two operations. Or other way could have been, I have taken this entire subarray and then this remaining subarray, because as I take one portion of this subarray and I can apply one operation, so all this will be gone. In the next operation, I will again take this subarray and this will be gone. Now, okay, if I have not done like this, then there could have been answer which could take more operations. For example, I take one subarray here, one subarray here, one subarray here. So you know operations required 3. I have to get minimum operations required. So you realize in this case, there was two ways how I could be able to achieve my answer as 2. Okay, let's take the next example. I have 1, 3, 2. It should become equal to 3 should become equal to 1. 2 should become equal to 4. So here the increase is 1. Here the decrease required is -2, or I can say decrease required is 2. Here the increase required is 2. So I drew the same thing. Diff increase required is 1. Decrease requires -2. Increase required is +2. Now, if we could have been sure that I have to take some specific subarray, then it would have been an easy question. But here, you never know that what could result in an optimal answer. But in this scenario, right now, we know the answer is 5. The question itself says answer is 5, which means I will take this as one subarray, one operation. Here, I will take one subarray, one operation, another subarray remaining, another operation, another subarray, one operation, and another one operation. So in total, I will have 5 operations required. Now you might ask, Aryan, why did not you take this entire array and then take this consideration? Okay, you can try that also. If let's say in one operation, I would have taken this entire subarray and I would have basically counted that diff, which means, okay, I have just remove this entire thing. When I say I removed it, which means this -2 technically became a -3. Now it has to incorporate this entire portion, right? Because you basically decreased, you removed this, which means you decrease these values. You decrease this. If you decrease this, which means this -2 again decreased, will become -3. Okay, one operation done. Second operation, you will maybe remove this. In third operation, you will have to ultimately remove this -3. So ultimately still, operations required were, okay, 1, 1, 2, then 3, 4, 5. Still they are 5. But still, Aryan, this example seems good, but how I am for sure that I can handle these cases separately? I'm still confused. Yeah, it is true. You have to prove things. Let's see. So now our ultimate maksad boils down to minimum number of operations required. And we realize that our diff could be positive above number line. It could be negative below number line. It could be a mixture above and below, as we saw here. Or it can be neutral also, which means, okay, my diff is 0. Matching, perfectly matching. Now, let's take things separately. If it is only increasing, we realized if it is only increasing, it is good for me that I will take this specific subarray, and then next time I will take this subarray. Operation required will be 2. Now you might say, Aryan, it also feels a bit hard to me. Rather, the approach which you told earlier, that I will take this as one subarray and this as one subarray. Ultimately, it should also work. Yeah, technically it is working here. But what if you went about the same thing in this example? So one you will take this, another you will take this, another take this, another take this. So 1 here, 3 here, 1 here, 2 here. That will be a higher cost. Rather, if I would have taken one entire subarray here, okay. So one operation done. Second operation I will do here. Third operation, and this is the fourth operation. In 4 operation, this entire blocks will come down to neutral, or I can say on the number line. So now we realized if it is only increasing, which means all the elements are actually above the number line, which means the diff is positive for all the elements, then it makes sense to kind of group the minimum, then go about and try to group the other remaining ones. Which means that if the number line would have been, let's say here the diff is 2, here it is 3, here it is 5, here it is 5, and here let's say it is again, let's say a 2, and here it is a 1. So it makes sense to group this entire portion. Again, it makes sense to group this entire portion. Again, it makes sense to group this entire portion. And then here I will remain with 4 and 5, then take it individually. Thus, taking minimum number of subarrays. But you might ask, Aryan, what about if I would have a 2 here, and let's say a 2 here, and let's say a 3 here? Okay, if a 2 and a 3 would have been here, I know it makes sense to basically this 1 would have covered this. So extra 1 and extra 2 I would have covered with another subarray, and extra 3 I would have covered with another subarray. So these could have been your answer. Now you might ask, Aryan, why not I take the entire subarray like this? Now, if this is a question, which means that you are arguing that I have a 2 here, I have a 1 here, I have a 2 here. So now we realized so far that it was easy for us to take this as one subarray. But now you are arguing, Aryan, I will take this as one subarray. Firstly, you cannot even take this. Why? Because if you take this as one subarray, you can only reduce by 1. So even if you take this entire portion, you will be able to only reduce by 1. Okay, which means, Aryan, I reduced everything by 1. So it will become a 1, it will become a neutral, it will become a 1. Now, to handle this scenario, you might say, Aryan, what I will do? I will take the entire subarray again. I will take the entire subarray again. If you take this, although you will take one operation, you will reduce both of them by 0, but then this will become a -1, which you will ultimately have to again take this entire subarray and you have to increase it so as to make it neutral. So either you could have taken these two individually, or if you would have taken this together, and then if you have taken this together, then this would have been decreased. So you have to ultimately increase it back. So, but Aryan, it seems like you have made this example, because what if I have more number of elements later on? Okay, we'll see on it later on. But you realize that roughly the crux is to take the entire subarray. Again, you might think of multiple edge cases. We will see that. But that is the reason I tried to show you that how you can build your own edge cases. Now, we were trying to handle this for only increasing. I will say the exact same will happen for only decreasing also. If the elements are basically down the line, same thing will happen. But what about the mixture? And here, the thing which we were trying to understand, what about this will help us, because here you saw things decreased also. So what about the mixture? When I say mixture, I mean, okay, positive also, negative also. Now, it makes sense to handle this positive separately, which means one subarray here, one subarray here. Okay, 2 operations, another here, 2 operations, 4 operations, which means I handled this separately, I handled this separately. Is it required always? Maybe not, or maybe yes, because at this point, when I was trying for only increasing, I was still curious that can't I take the entire subarray? And there we realized even if I would have taken the entire subarray, which means I would have taken this entire subarray itself and I would have decreased it. So this would have become a 1 and a 1. The diff would have reduced in 1 and 1. But here the diff would have increased to -3. So the benefit, because if you would have not taken the entire subarray, you could have done what? You could have individually reduced them. Okay, reduce them by 1, reduce them by 1. So basically you were actually having a benefit of one cost if you would have taken this together. But now that one benefit actually is incurring you the equal number of costs because things are actually going down for the things which are neutral. So it makes sense, okay, individually to handle them will give you the same cost. But you might say, Aryan, what if I had more number of elements here? Maybe then the cost would have been reduced. I will say no, because here if I had 2, then you might say, Aryan, I will take the entire subarray. Now I'm encountering more elements. I will say that is your Brahm, which means that if you will take all of them, which means here it will become a 1, it will also become a 1, 1, 1, 1, 1, 1, but still this will become -3. So technically you increase the cost again by 1. But if you would have taken them individually, still the cost would have remained same. If I have taken 2, 2, there are 2, there are 2, there are 2. If I would have taken individually, so on one single subarray, the cost will reduce by 1. Sorry, this will become a 1, only 1, the cost is 1. And here again 1 and 1. This operation I would have done in just one single cost. So the thing which I was doing earlier as -3, I just took one cost and decreased both of them by 1. I took one subarray. So now it makes sense. It makes sense that I can handle these things individually. It is of no point if I cannot increase everything. I cannot increase everything. It is of no point if something in the middle, as you can see in this example, it was increasing, like the diff is positive, 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 and negative. It is of no point to go to, because it is of no point to take a subarray which has both positive and negative, because I will apply only one operation. Either I will increase or decrease. Anything whatsoever I do, I will make other one as one more step. So ultimately I have to handle that other one. So it is very good to handle increase separately, to handle decrease separately, to handle increase separately. So diff is positive, handle separately. Diff is negative, handle separately. Because we realized that even if we could have handled this diff even if we could have handled these two diffs as positive together, it could have resulted in increase diff value for the negative diff. So ultimately you might say, okay, now it feels good. But still you might say, Aryan, what if I have a neutral in between? Same applicable, exactly same application. Because even if I could have taken this entire portion as an entire subarray and I could have increased, or basically like the diff is 2. So I would have tried to decrease the diff by taking one subarray. So they all will become 1. They all will become 1. But this will become a -1 then. The diff here will actually be -1. So I will again have to handle it separately. So now we realize that we will handle the positive, negative, positive, neutral, positive separately. Now, when we handle positive diff, we handle negative diff. Neutral, there is nothing to do. Simply ignore them. Again, I am only talking about a diff between nums of I and target. So now, I realize I will handle them separately, which means this entire positive diff array should be handled separately. Entire negative diff, if I let's represent the exact thing as negative, entire negative diff array should be handled separately. Neutral can be simply ignored. Now, when the task is to handle the positive diff separately, and the same will apply for the negative diff also. They will be handled in the same exact fashion. It is just that how to handle them. That also we have seen earlier. How we will handle them? We know that ultimately it is most optimal to take this entire array, which is having the minimum, value, right? As you can see, 1. So I will take entire subarray. I'll reduce all of them by 1. I'll take entire subarray. Why I did not, again, there's next operation which I can take. Why I did not take again the entire subarray? the same application. If I take the entire subarray again, I know that this has now become neutral, which means this has now become 0. So now the issue is, if this has become 0, if I take the entire subarray again, it is an exact same replica of saying the array after taking this one operation of the entire subarray, the array has now become 1, 2, 4, 0, 1 and 1, which means this is positive, this is neutral, and this is positive. So these again should be handled separately. Now you might ask and say, Aryan, things good, awesome. This is the ultimate observation which we have. How to solve it? How to write it in the form of a code? That is a question. And that is the biggest task, because now ultimately you will have to make sure, okay, you will firstly have to group all these diffs as positive, okay, then nothing, then negative, and so on and so forth. Even after when you have grouped them, you will have to place one subarray according to the minimum element, then another subarray on the basis of what is remaining on the left and the right portion, and there could be multiple portions which could emerge. So the code complexity, again, to handle or to code them or to code it will be a very tricky task. How to handle that? People might start thinking the recursive form, but it will, again, you can try recursion, but it will become more complex. With the complexity, time complexity also will be very high. So how to handle it? We realized ultimately how this thing looked like. If I just show you this, I took one subarray here. Okay, these all things reduced. It became 1, it became 4, it became 4, and it became a 1, 1. Now I took one subarray here. Again, just see how things are happening. Here I again took a one subarray. So these became a 0, 0 now. These became a 1. These became a 0 and a 1 and a 2. I took a one subarray again here. This became a 0. This became a 1, I guess, or 2. Okay, no matter what, it was diff of 2, so it should become 2. And now ultimately I have these two subarrays, which I will take two operations here. So 1 and 2. So ultimately operations required will be 1, 2, 3, 4, 5 and 6. How to solve it in code is a question. So we will see this and we'll try to handle this. How? Let's go incrementally. So in the very beginning, my answer, again, right now I'm showing you for the increase when the diff is positive. Same will apply for diff is negative. But now I'm going in this direction. So I will say, okay, currently I have my bar at 0. Currently I have my bar at 0. When I say bar, I mean the subarray bar. This subarray bar. So I reached at 2. So I will simply say I reach at 2. My bar was at 0. I reached at 2, which means I will have to take two subarrays, which means he will continue taking two subarrays. So you can see he will continue. So I will increase my answer by 2. Okay, I will continue taking two subarrays. Again, this is saying I will continue taking. It is not saying I will continue taking two subarrays up till the end. No, I'll continue taking two subarrays, which means that next time it go on to next number, which is 3. I know so far my bar limit was up till 2. So I was continue taking two subarrays. He is saying 3. So now I will say, okay, I need to take one more subarray starting from here. So I will continue taking 3 subarrays now. Okay, now I go on to 5. My bar was at 3. Now I will say, okay, I need 2 more subarrays. So he will say, I'll continue taking 5 subarrays. Okay, he'll continue taking 5 subarrays. So which means 2 more subarrays added. Now they will all drop down to this one. Ultimately, I was saying I will continue taking 5 subarrays. I dropped down to 1, which means one subarray is already there. But now these all 4 should be discarded. So my bar now came down to 1. But still, as I had earlier 5 subarrays, so 1 also I have subarray. Okay, continue taking that. Continue taking that. But you see, my bar has come down to 1 now. Next time, I got a 2. Oh, I was continue taking 1 subarray. I received 1 more subarray. Okay, so increase the answer by 1. So increase the answer by 1. Now continue taking 2 subarrays. My bar has become equal to 2. Continue taking 2 subarrays. Again 2. My bar was actually at 2. So continue taking 2 subarrays. And ultimately, this is my answer. This is my operations or subarrays, or basically operations required to make this entire diff back to neutral. And the same thing you will repeat it for your negative thing, which means your diff is negative. Repeat the same thing, bring them back to neutral. Let's see the code. Code is exactly same. We just take increase operation, which will say current bar I had. Current bar in the very beginning was 0. I know when my diff is more than, again, this is right now condition I'm handling only for the positive diff. This I'm handling only when my diff of I is more than 0, right? If your diff of I is more than increase operation, which means your diff of I was more than your bar, then firstly make sure what is the current bar, which is the increase operation, and what is and where you want to go, which is diff of I. Then that specific difference you have to add in your answer. You have to add in your answer. So firstly, I will find extra, which means current bar, which is this, and diff of I. I'll find the extra and I will add that in my answer because that's what I needed. But I also need to make sure now my current bar has reached to what? Now my current bar has reached to, wow. Now my current bar has reached to that specific diff of I. So my current bar has reached to that specific diff of I, which means current bar, increase operation, has now reached diff of I. But this is when my diff of I is more than my bar. What if it is less? If it is less, I know one thing for sure, that I already have my, I will bring my bar down, right? Because my diff of I has now become 1. So I'll bring my bar down only. Okay. So I will bring my bar down to diff of I, which means now my bar will become equal to 1. And this is the operation how your bar will keep on moving depending upon your diff of I or next diff of I. Now, in this entire scenario, just do one thing, that while you are handling your positive bar, because see, this is increase operation, which means you are only handling when your diff is more than 0. Make sure as soon as you encounter some negative diff values, you need to make sure you should reset your decrease operation bar, because decrease operation is the same way you had increase operation bar, which is being changed. Make sure as soon as you encounter, make sure that you are handling right now positive diff. So be prepared next time you receive a negative diff. So your decrease operation should start from 0 itself. So whenever I am handling my positive diff, I am being prepared as soon as maybe in the next future I receive a diff which is negative, I need to make sure my decrease operation is being reset to 0. And this is only when in the start of my decrease in my start of my diff, which is negative, that specific interval. And then while you are handling your diff which is negative, make sure be prepared for the next time when increase operation will come, which means increase operation should also be reset to 0. And as soon as you encounter any positive thing, any positive interval, any positive diff interval, you again will reset. You again can start from your increase operation back to 0 and then can continue that here itself. So this is your code, entire code, right? Again, same code will repeat for your diff when it is negative. So firstly, I will grab the diff, which is diff of I will be nums of I minus target of I. Now I will say increase operation, which is the bar for increase, it is a bar for decrease. Now, when the diff is positive, which means I am handling my positive diff. I told you when I handle, if the current diff is more than the bar, make my bar reach that specific diff. So extra operation required will be diff minus bar, and make sure to put that bar equal to your diff, and always be prepared for the next decrease operation coming ahead. So I will always make sure I will reset it. Same operation I will do when my diff is negative, which means only thing is, as a diff is negative, you are comparing positive numbers. So make sure to do a negative in the diff every time and repeat the exact same process. Just do a negative in the diff because the diff is now negative. You are comparing only the positive numbers. But when it is neutral, make sure to reset your bar for either in upcoming increase or decrease diff. So reset your bar for upcoming increase or decrease diff, and ultimately this is your answer. As you can see, time used will be simply O of n. Space used, although in my case, would be O of n itself because I have made a new diff array, but you can handle this diff in here itself. You can make a new diff variable which will be nums of I minus target of I. So your space will actually become O of 1, but in this case, just so that to understand much better, I have taken a new diff array itself because I have made an example. I hope you guys got it. If yes, then do smash the like button. Comment down below what you learned and what you missed. And yeah, see you goodbye. Make sure to connect on Twitter. X called nowadays. Bye bye.